So e to the first is a number. E is very similar, and the idea is the same as pi. It's a number that's being represented by a letter because it's used frequently. It's used frequently in growth problems. And it does represent an exact number. Now, the problem is it's a number that never ends, just like pi. And so we usually leave it in terms of e, and that is 2.17828? What? 7128. And it keeps going. You're never going to actually find that number. Everything that we do on these problems for today is going to be left in terms of log or left in terms of e. So ln, remember, is the same thing as log base e. And we are going to be using the natural logarithmic function as well. So either we're going to be in natural exponential function or we're going to be in the natural logarithmic function for the answers. So either there's going to be an e or an ln. There will not be both. Okay? One of the hard things on this is we have to simplify our ln's when we have it. That means we want to get down to prime numbers. And I will show you how to work with that. So if we have ln of e to the 3x equals 12. This is the same thing as me saying log base e of e to the 3x is equal to 12. So we are going to be using those logarithmic properties that we talked about last week. So if we have a log with the same base as what's behind it has in there, so like e to the what power, if these match, they cancel out, leaving us just the exponent as the whole thing. Just remember that exponent can go in front as be a product. Then we'll solve this by dividing by 3. X is equal to 4. That's your answer. There are going to be about 4 questions on today's assignment where you'll come up with an answer just like this, where it's just a number, no e's, no natural logs. The rest of them at e or at ln is going to be involved. What do you think I'm going to do first on this one? Multiply. So we're going to combine just like we did on Friday. So Friday, whenever we had the addition, we combined it with the multiplication. So that's going to be ln of 4x is equal to 7. Now, if we had a log only on one side, what did we do on Friday? Not set them equal to each other. That's when we had log on both sides. We fished it. Remember, this is log base e. So, e to the 7th power is equal to 4x. What would I do to solve that? How do I get x by itself? Divide by 4. So the answer is e to the 7th divided by 4 is equal to x. Done. So our goal is to get x by itself. To do that, we are either going to have to most of the time, we're going to end up fishing today. We're either going to convert it to a logarithm or we're going to convert it to an exponential. Whichever one it's not in, we're converting to the other. Unless one of the properties it can be applied. So the properties you'll be looking for are where your base match or if you have log of 1. Your log of 1, any log of any base to 1 is what number? 0. So there's 3 properties that you'll be looking for, or actually technically 4. That's one where the bases match. There's 2 of them that deal with that, one with the exponent of 1 and one with the exponent of anything else. You'll have one that we didn't even touch last week. That's whenever you have the exponent being raised to the log. And then we have the one where it's log of 1. So those are the 3 that you're going to find. When you find those, the answer is not going to have any e's or any logs. But everything else is going to have an ln or an e in the answer. So let's look at this problem. Do we have the log by itself? So that means we go fishing. So we have e to the 3rd power is equal to x minus 2 cubed. Now, the powers match on each side. So that means we can take the same root on each side and it cancel out. So I can take the cube root, and that's going to cancel out the exponent. It will every single time give you what's being raised to the power set equal to each other. So e equals x minus 2. What would I do to solve this? Add 2. And that is your answer. Just like when we were dealing with the expanding condensing, sometimes it doesn't feel like you're getting to the answer because it does look complicated. But if there's no variable, no x on the side where everything else is, and x is by itself, you're done. What do you think we might do first here to solve? Divide by 2. E to the x is equal to 5. Now, we need to get to where we have the x by itself. We're going to have to fish it. We're going to turn, this time we're going to be turning it into a log. Because it's in exponential, we turn it to a log to solve it. So if it's an exponential, it converts to log. If it's in log, you convert to exponential. It's basically a big cycle. If it's in one form, change it to the other to solve it. If it's in the other, change it back. And so, if I fish this, it's e is my base. The answer is 5. And the exponent is x. So, log base e of 5 equals x. What is the best way to write log base e? ln. You don't have to write it both ways. You only have to write it as ln. I am going to, for note purposes, write it both ways each time. Just because I want you to make the connection of where the pieces are going when you convert it. That's your answer. Now, when you get to this answer, always check, is this number prime? If it's not prime, like let's say it was 25, that's 5 squared, so that's 2 log ln 5. So you look to see, especially is there any power this is raised to simplify it out. What are we going to do here to solve? Which form are we in, exponential or logarithmic? Exponential, so we need to change it to log. So we have e to the 2x minus 3 equals 1. So we're fishing. log base e of 1 is equal to 2x minus 3. That's ln of 1 is equal to 2x minus 3. Any type of log of 1 is always what? Now we're solving this equation. What do I need to do next?
Plus 3.
Giving us
Divide by 2.
and so 3 halves is equal to x. So we didn't have a log in the end on this one because we had the property of log base anything of 1 is always 0. So that's one of the properties to look for that will cancel out and give you no logs. This is the property we really didn't mess with last week. All the ones we worked with last week were in logarithmic form that we're messing with. This one's in exponential that we're raising to a log. First thing you want to do is make sure your bases of your exponential and the base of your log match. So I'm just going to rewrite this to show that they do. Again, that's not something I would require. But this base and this base match. So that means they cancel each other out, leaving you just the exponent. 4x is equal to 20. What do I do next? Divide by 4. And so x is equal to? Done. Why was there no e or log in this one? Because it canceled out. Ooh, I forgot to erase this one. So, number 7. What is different about number 7? There's a number being added at the beginning. So we need to get it to where it's the exponential by itself.
Can you subtract 30 by 30?
Subtract 30. So that means we have negative e to the 3x is equal to negative 21. Have we worked with any negative exponentials? So what do you think we might do? Get rid of the negative sign by either multiplying both sides by negative 1 or dividing both sides by negative 1. And so that's going to give us e to the 3x is equal to positive 21. Now, Allison, you were saying what we need to do next?
Fish.
Go fishing. So log base e of 21 is equal to 3x. Now what do I need to do? Is the best way to write it as log base e? ln of 21 is equal to 3x. What do I need to do to solve this?
Fish
Look at the operation that's connecting the number, or what operation is connected to the x. Multiplication, so we need to divide. If it's an exponent, that's when you take it and make it to logarithmic. And so ln of 21 divided by 3 is equal to x. So is 21 prime? No. Is it something taken to a power? No, but it is two things being multiplied. So this is another way of writing this is ln of 7 plus ln of 3 divided by 3. So look for the powers. And one of the things that you can end up with is something like ln of 4 divided by 2 is 4 prime. I can rewrite this as ln of 2 squared over 2. What happens to this 2? So we have 2 ln of 2 divided by 2. They cancel. And that's the reason that they will often, you want to go and see if you can write it in any primer, because it can sometimes simplify your answer. If you can write it in prime notation, especially look for things raised to a power, because that's what can simplify. It's not as important in this case because is this more simple or is this more simple? The top one. In this case, which is simpler? The first or the last? So what helps me get to this point is this being a number raised to a power. So look for your perfect squares, your cubes, things like that. There will be some that will show up in your homework. They will simplify and they will get you a simpler answer. You are going to be doing a maze. That means sometimes your answer may not match. Look to see if this is the reason, because it may be. Most of the ones I came over and they're like, I can't find my answer. This is what it was.